morning, and welcome to the American Public Works Association's Talking Top Tech webinar series. Today's panel discussion will be 1 hour in duration and is titled Talking Top Tech, Preparing for Implementation of Automated and Connected Vehicles. Due to the free-form format of the program, it is not eligible for CEUs. My name is Rita Cassada, and I will be your facilitator today. I'm an education manager at FHWA, and I have a BS in mechanical engineering from Kansas State University and an MS in engineering management from the University of Kansas. I'm a licensed professional engineer in Kansas, and before joining FHWA, I served as the Public Works Director for the City of Lewisburg, Kansas. A recording of today's program will be available in the FHWA Members Library and on YouTube within 1 week. FHWA members can log into the library to access content free of charge. Not an FHWA member? Take the members library for a test drive. Spend 2 weeks accessing all the materials in our members library for free. Look at the link to sign up in your email today after the program. Today's session is interactive, so if you have questions for our speakers, please type them into the chat pod. You may do this at any time throughout the program. When you are in full screen mode, you can access the chat pod by hovering the mouse at the top of the screen and clicking on the chat icon. Before we begin today's panel discussion, 2 of our panelists will give a short presentation. Mandy Anderson is the project manager at Garver, and Jamie Gilbert is the Director of Operations at GBA Systems Integrators. Mandy and Jamie, before you begin the presentation, please give us a brief overview on how you are involved with the implementation of automated and connected vehicles. Thank you.
Thank you, Rita. My name is Jamie Gilbert. I'm the Director of Operations at GBA Systems Integrators. I've been a traffic engineer for the first 20 plus years of my career with George Butler Associates. And then in the past 10 years, I've been leading a group of engineers and network specialists doing communication systems, because as part of my role back with GBA, we were building very complicated, very unique traffic solutions, but we were always having problems getting the technology to work. So we developed the company to do that, and now I'm getting more involved in connected vehicles, automated vehicles, smart city implementations, and we're finding out more and more how these things need to really run.
Yep. Good morning. My name is Mandy Anderson, and I've worked in this industry quickly approaching 20 years. I've been with Garver since January, was hired to sort of lead their traffic technology unit. And then prior to that, I worked with Jamie for nearly 15 years in really traffic and transportation operations, focused on ITS and signal coordination. And as we were working on these projects, we quickly learned that as the conversation evolved around autonomous and connected vehicles, that a lot of communities weren't prepared, didn't know where to start. So that's kind of the...
Didn't know what they didn't know.
Right. And Jamie and I actually both serve on the APWA subcommittee for connected and autonomous vehicles. I guess so with that, let's jump right into the presentation. Again, we're talking about preparing for the implementation of automated and connected vehicles. And we always like to start with sort of, here's what we want you to pay attention to while we talk. To understand the impacts of the smart city and connected vehicle technology on public managed communication. So how does a municipality kind of prepare their communication system for what's coming? Identify the impacts of the evolving data available, because there's lots of it, and how do you use it? And then understanding the importance of investing and building your strong communication system really right now. So when you look at transportation, there's kind of 3 general generations. The first one is walking, and animal-drawn transportation. The next one was what we call Gen 2, is really the industrial revolution. And then Gen 3 is this smart kind of transportation generation where we are now.
And smart transportation really is the overlay or the injection of technology into all the things we've been doing during the Industrial Revolution. The road systems, the transit systems, they're all there, but now we're trying to make them smarter, make them more efficient. Try and gain 2, 3, 4% increases in capacity because they make huge differences. So what is Gen 3? It's like I kind of mentioned, it's the integration of that technology, and it comes in a lot of different ways. It comes in connected vehicles, automated vehicles, which is what we're going to concentrate on today, but there's also other things we have to think about. It's IoT, the Internet of Things, and all the different things that are starting to communicate with each other. Big data, data coming from lots of different sources, and then how do connected and automated vehicles start to function in a community setting? Is it solely just the car being more efficient going up and down the roadways, or is there things that are starting to filter out into other areas? So when we talk about those things, one of the big things is it's already happening. It's just a lot of people don't really realize where we are in the cycle. Right now, we already have lots of different communication networks between cellular, the fiber optics, the point-to-point radios, all these different systems, and they're starting to communicate and make data more available. This little graphic shows right now vehicles are talking to sensors, the vehicles are starting to talk to vehicles talk to infrastructure talks back to vehicles. We're getting mobile devices where pedestrians and bicyclists are starting to integrate into the communication system. And as you can notice, everything revolves around the communication system. Whether it's cellular or government-owned and managed, there's just so much we have to make sure we understand. The impacts of all these things is the traffic networks, the things that we built in the 70s, 80s, 90s, twisted copper, fiber, radio systems to manage our traffic and ITS devices. Now they're being utilized for much more. Security, monitoring, operations are all happening. The higher needs, the higher bandwidths create the big data, and it puts a higher dependence upon higher capable systems. Twisted copper pairs are great for timing signals. They're not really good for carrying video, so we got to figure out how to bring these things together. And kind of one of the big answers we're seeing is the public-private partnerships, the P3s, where people with physical infrastructure are sharing their networks for operations and maintenance because it helps with the cost implications.
So you're also seeing partnerships across municipalities.
Exactly.
Between the fire, the city, schools, there's lots of opportunities for sharing, fiber too.
Well, and when you talk about that, there's also most people that are driving their vehicle don't realize they leave one city and drive into the other. They want the traffic systems, they want all of these networks to just function seamlessly no matter where they physically are. So one city can't be an island anymore. You actually have to look at these things on a regional basis, have cooperation across city, state, county lines. So preparing for what's next, probably a couple of really big things that are going on is the automated traffic signal performance measures. It is a great trend that traffic engineering is moving into where we're starting to do things in real time or near real time and using the information we're collecting to make those small incremental improvements. Instead of timing your signals every 3 years, you're doing it more on a continuing basis where you need to. We mentioned the regional smart community deployments. That's huge, getting the people to cooperate. And then also trying to figure out how to get more bandwidth and network capacity.
So if you look at ITS America's vision, it's a better future transformed by intelligent mobility. So the one that is safer, greener, and smarter. I was in some meetings with the Secretary of Transportation for the state of Kansas, and she said, you know, as we look to the future, the transportation system in Kansas will be used for moving people, data, and freight. So there's a great conversation going on right now of how do we use our infrastructure to not move only people and freight, but also use that right away to move data.
Yeah, data is suddenly becoming something that the DOTs and agencies are starting to realize has value in and of itself, and there's things that we don't even know we're going to use the data for, but they're coming.
Yeah. So how do we become better owners of our infrastructure system? And how do we prepare for the future? So you do that by planning, designing, implementation, and then through the operation. So when we talk about planning, we want to look at the best practices. And that includes planning a smart community ecosystem, one that it encompasses lots of
it's a broad platform with goals for all the different uses you're trying to do. You need to actually have a plan of what you're going to do in your city community before you can implement anything. If you don't have a plan, you're just kind of swinging at low-hanging fruit. You really need to have a direction.
And like the slide says, set very, very specific goals.
Yeah.
This is who we are today. This is who we want to be in the future. And these are the goals that we need to achieve to get to reach those goals. And then your early action plan. Use some of those pilot projects and other opportunities to implement these strategies.
From a design, it really comes down to those best practices again, or having a updated standards and specifications. It's amazing when you get involved in projects and people are still specifying equipment that's 2, 3, 5 generations old. We need to have standards that are more flexible because technology moves so fast. You really need to be defining the outcome of what you want the technology to do, not the exact piece of technology, because it changes. We got to adopt the technologies that are proven. We don't need to wait for 5G or 6G or the next big thing. There's a lot of good, capable technologies that are relatively inexpensive to utilize. If you have needs today, we should be solving the problems today.
And then implementation. Create a solid, broad technology foundation. And that means look at your fiber that you have in the ground. Is it, where you need it? Are there other opportunities for communication?
Do other people have fiber you can utilize? Can you partner with them?
Yeah. And then as we just talked about in the planning, invest in your goals and your approaches. And like Jamie kind of alluded to in the previous slide, act now. Tomorrow's technology will be tomorrow. It's not solving the problems that you have today.
Yeah. And then from an operational standpoint, this is probably where most organizations have the most issues. We've spent a lot of money, we've bought some great systems, we've got this cool technology, we're using 10% of it. It's not being maintained, it's not being managed, it's not being operated correctly. I had a meeting a few months ago with an IT manager in a Midwestern city, to be nameless, and he said, we're really good at buying things, but we're really, really bad at owning them. And that was really a very succinct way of saying they don't take care of what they have, so they're working on trying to come up with SOPs to do a better job. And they're training their staff to take advantage of what they have. Probably the most important thing on an operational standpoint is you have to think program. It's not about project delivery. It's not about getting the next thing done and off your desk. It's about standing up a program where every year you're making those little incremental improvements that start to build a foundation and a program that can be sustained and used by lots of different people for lots of different things.
Okay, so here's kind of a summary of action items to keep your have an effective system for your effective system management. Act like Jamie just said, actively maintain and manage your existing traffic signal system.
Yeah, and by actively, we actually mean that. Make sure your firmware and all your controllers are updated. Fix your switches. If you've got issues for redundancy where you have opportunities, build them. Make your system work better. Number 2, improve your transportation communication network robustness. That's make it better. If you've got a 10-100 network, turn it into a 1 gig network. If you've got something that's just got a whole bunch of stud or spur lines, and if one thing gets cut, everything dies, figure out a way of creating a loop so you can bring Tom back the other way. And partner with people. There are other people out there that have network needs just like you. Figure out who they are and figure out how to partner with them.
And then finally, develop performance measures. How is your system performing? Is your system improving the efficiency of traffic operations across your system. So really, like James said earlier, develop those performance measures and measure what matters.
Yeah, and really the thing is, when you start to interlay or overlay the technology into the infrastructure, you're not making improvements like a brand new interchange, but you're going to make 1, 2, 5% improvements for everybody that touches your system. It's hard to measure, but it is hugely important to the people that you're saving 10 minutes of time a day for. So that kind of wraps up our presentation, so we'll pass it back to Rita.
Thank you, Mandy and Jamie, for sharing that great presentation with us. Now it's time to begin the panel discussion portion of the program. Joining Mandy and Jamie on the panel today are Fievel Salim. He is the ITS Branch Manager and MCDOT Smart Drive Program Manager at the Maricopa County Department of Transportation. John Corbin is the Automated Vehicle Program Manager at FHWA Office of Operations. And Robert Brown is the Director of Public Affairs for Too Simple. APWA is delighted to bring you such knowledge and experience. Mandy and Jamie both gave us an overview on how they are involved with the implementation of automated and connected vehicles. Now, Fievel, John, and Robert would like to give you an overview of how they're involved with the implementation of automated and connected vehicles. Fievel, would you like to go first?
Sure. Good morning, and again, my name is Fievel Salim. I'm with Maricopa County Department of Transportation. I serve as the Intelligent Transportation Systems Branch Manager and MCDOT Smart Drive Program Manager. SMART in this case is an acronym for Systematically Managed Arterials. We launched the MCDOT Smart Drive program to test, develop, and implement emerging technologies, included connected and automated vehicle technologies. We have developed a test bed in Maricopa County in the Anthem area. It's an 11-mile long test bed with 11 intersections, and we are testing a variety of applications, including multimodal intelligent traffic signal systems, alerts and warning systems, work zone advisories, and other applications. It's a pleasure to be joining the panel today, and thank you, Rita and Catherine, for the opportunity.
Thank you, Fievel. John, would you like to go next?
Sure, thank you, and I'll share in Fievel's gratitude for the opportunity to be part of what's already a great discussion. Thanks to Jamie and Mandy for a very informative kind of foundation setting. As was noted, I'm for the last 2 years have been the Automated Vehicle Program Manager or an Automated Vehicle Program Manager within the FHWA Office of Operations, which is one of the headquarters program offices. We work closely with another part of the organization, which is our Highway Research and Development Office out at the Turner Fairbanks Highway Research Center. And then also one of our primary purposes is to support our 52 division offices, which are distributed across the country. Prior to my role with the Federal Highway Administration, which actually started about 5 years ago, I served primarily in state departments of transportation, specifically in Illinois and Wisconsin, and finally in Iowa. Majority of my career was with the Wisconsin Department of Transportation, ending as the Director of Traffic Operations, a role that I also served in the Iowa Department of Transportation. Also, while with Wisconsin, I was, for a period of time, the state traffic engineer. So currently my involvement in automated vehicles has involved a lot of listening, and many on this call, including my co-panelists, participated in and contributed to something called the National Dialogue on Highway Automation, which was a series of 6 workshops with a lot of interactive kind of eyeball-to-eyeball contact and conversation to better understand the needs, particularly of transportation agencies, but also industry partners, in anticipating and beginning to accommodate the integration of automation and automated vehicles into the roadway network. And so as a byproduct of that dialogue, which was also informed by some requests for information and requests for comment, which again benefited from the insight and expertise of those on the panel as well as those of you on the call. Thank you for that. We also understood that there was a key opportunity to frame out more of a strategy as a basis for a national vision related to automated vehicle integration and roadway automation readiness. And so just at the start of this month, we kicked off internally, administratively, a project that's being called the National Roadway Automation Readiness Framework and Concept of Operations. A key part, in fact, the cornerstone of that project will be actually intensified and more focused stakeholder engagement to understand what the Federal Highway Administration can offer as far as a framework and kind of a process and a methodology for relating the automated vehicle and the automated driving system more consistently and more predictably to the infrastructure systems, including, again, as Manny and Jamie so expertly kind of contextualized, is increasingly a cyber-physical roadway infrastructure system. So with that, I look forward to further discussion and interaction with the questions as well.
Thank you, John. Robert, would you like to give your overview?
Yes, good morning, and thank you for having me. I'm in Tucson, Arizona, where we are a developer of self-driving trucks. To date, we have 35 trucks operating, hauling revenue in and around Arizona, New Mexico, and Texas. We're obviously in the testing and development phase, so we have a trained CDL driver behind the wheel and an engineer riding a co-pilot. But we're also hauling cargo every day. We just finished a pilot this May with the United States Postal Service and recently announced the relationship of hauling UPS cargo in Arizona. We are one of many developing this type of technology. We're all relatively focused on that I-10 corridor from LA to Florida, and as one of the folks that participated and that followed John around the country in those national dialogues, I appreciate what you are all doing from the public sector, and as a private sector developer, we work very closely in our neighbors with Arizona Department of Transportation, New Mexico, and Texas, along with our law enforcement and, of course, our federal partners in Washington, D.C.
Thank you, Robert. Now we're going to get started with questions for our panelists, and just a reminder to send your questions in the chat pod at any time so we can get to your questions and get them answered. The first question we had was for Mandy. What is one of the first steps a city can take to prepare for the future of transportation?
Right, great question. So what Jamie and I are seeing is oftentimes communities don't know what they have. So we've seen, we've run into this kind of across the board within our footprint that our firms work in. And so we've kind of taken the approach that cities really need to go through the system engineering process. So kind of identify what it is that they have, what it is, or really who they want to be, 5, 10, 15 years from now, and develop a strategic plan that's scalable to get from, point A to point B.
Yeah. Generally what has happened is a lot of the networks and systems were kind of organically grown, and they were done 25, 30 years ago, and then they've just been slowly expanding. And a lot of the expertise that first built the systems has retired or moved on. So there's really a lack of knowledge about what the systems they're running are, what the capabilities are, physically where things are placed. Everybody can find the signal cabinets, but all the pieces in between are just kind of there. So having that systematic approach where you identify what you have, what you want, what you need. The hardest question is identifying who you want to be. Are you solving a traffic engineering solution only, and your only use of your network is going to be signal timings, or is it going to be with ITS, with smart cities technologies to support automated or connected vehicles? Because all of those things kind of build on each other, and you have to really have that vision to make it work.
Thank you, Mandy and Jamie, for that. And it looks like, Fievel, did you want to add to the answer to that question?
Sure. So I would like to share our experience and what we have learned over the years is that's really valuable for the agencies to try out in a real-world environment. And it could be as simple as picking up one location where you have a power, you have a pole, and you can install the roadside unit and maybe equip one vehicle, but just start getting your feet wet. I think learning is really important, and learning in a real-world environment is extremely valuable in this case. Let me add a little bit more and appreciate Jamie and Mandy presenting that slide which shows the connectivity between the infrastructure and the vehicle. I would like to share a broader environment of this ecosystem, which I think is really important for the agencies to visualize and take into consideration. So if you see one box, that slide that Jamie and Mandy showed, that over-the-air communications, now add to that 3 other boxes. So one box is your TMC, which is your backhaul. So you have to have connectivity from that roadside unit to the TMC. And then think about another box, which is all the additional applications that we will be running in the connected vehicle environment, including security, which is really a new thing. So my point is that the agencies, it will be really helpful for the agencies to understand the full ecosystem as they develop their programs. Thank you.
Thank you, Fievel. The next question is for Robert. When will we see autonomous trucks without the drivers in the cabs on the road?
Yeah, so I love this question because it is a bit of a two-phase approach. So we're pretty confident from a too simple perspective that you'll see a quote-unquote self-driving or driverless truck probably by 2021, 2022. But that is going to be on a very, very limited scale. We're talking maybe 1 to 2 routes, most likely in and around Arizona, as a proof of concept, to the world, pretty much, from a regulatory perspective, from an industry perspective, from a public acceptance perspective. Obviously, we are still working towards a commercial deployment, and that means working with the OEMs, which are in our case is Navistar and PACCAR, where we can actually get a Peterbilt truck with the autonomous package. We're shooting for 2024 or 2025, most likely at the earliest, where large fleets like UPS and the Postal Service can purchase a truck from the OEM, and Too Simple is currently a fleet, but then at that time we get to be transportation as a service technology company. So that's kind of what we see the Too Simple roadmap. Obviously, the folks in the industry have in our industry have done a few pilots. Around the country, from California to Florida, but when you're actually going to see a commercial product at scale in multiple states, I think we still have quite a few years ahead of us.
Thank you so much, Robert. Just got a question in from Mike. Is there a best practice for analyzing the cost and benefits for the locations and amount of bandwidth for fiber optic facilities? And is fiber optic the optimal product for data infrastructure? Jamie and Mandy, do you want to start with that, and then any of the other panelists can add in on the answer?
Yeah, sure, be happy to. To be honest, there's really no optimal product for data infrastructure. A lot of it depends upon the physical location you are at and how big a city you are. If you can afford it, fiber has absolutely the best flexibility. It can grow with you. The physical fiber isn't what controls bandwidth. It's the switches and devices you put on the fiber. So once you build that fiber backbone, you can upgrade it very easily by changing your switches and routers and those kind of devices. But we have a lot of clients around the country that can't afford fiber everywhere. So they put it in certain locations as backhaul and critical corridors, but then they use radios or cellular devices or microwave. There's lots of other medias that can be definitely utilized. Go ahead.
I was going to say, and it depends what sort of data you're carrying.
Exactly.
Is it video versus?
Video is the #1 bandwidth hog. If you've got a lot of cameras, if you're going to do a lot of operations or viewing of your system for surveillance or operations with video, it uses the most bandwidth. So then fiber becomes much more reasonable. The great thing about the bandwidth, though, is it's always getting better. The systems are getting smarter, so they're using less bandwidth to do things. So really what you need to do is take a realistic approach. Again, know your vision. What are you trying ultimately to be in your community? And then the infrastructure will kind of start to fall out of that. For the locations, the amount of bandwidth that you need, it all comes down to what kind of data you're trying to transmit. Given everything being equal, I'm always a proponent of fiber, but sometimes it's just not realistic. Anybody else got anything to add?
Yeah, you know, so this is John Corbin, and I'll just maybe resonate with an earlier observation you made, Jamie and Mandy, regarding kind of the need to define, and I'll presume to use maybe slightly different terminology. You can salvage it or correct it as necessary, but the challenge to define your community's identity, a specific community's identity and kind of strategic objective from the standpoint of investing in any technology, including transportation-related technology. And I think the question is very insightful because it points at the need for maybe a more strategic network view of community-oriented and you know, public sector infrastructure across multiple systems, kind of investment or business case, and talking about cost effectiveness. And I think the challenge is to look at that kind of not just at the network level and strategically, but also as kind of a cross-sector opportunity. And so as opposed to looking at a specific location and a specific narrow tactical need in isolation, I think a case can be made, and there's some experiences emerging both at the state, you know, and multi-state corridor level or interstate corridor level, as well as the municipal and smart cities at the municipal and smart cities context, of looking at not just a function within a public agency, but more holistically across the public agency in terms of needs that might relate not just to transportation, but to public safety and emergency response dispatch, to, you know, library and information systems related education, and then looking beyond just the public sector at you know, where telecommunications companies might be looking at accelerated anticipation of 5G. So I say that all probably ending with a question mark, deferring back, Jamie and Mandy, to your expertise and insights perhaps in examples of that. But I think it's a great question and an insightful conversation.
Great. Thank you, John. And I think you've covered on some of this, but I'm going ahead and ask you this question, Jamie. Is there anything else you want to add about how cities can stay current with technology improvements?
Oh, wow, that's really an open-ended question. The biggest thing is to become educated. Don't try and do everything yourself. Like Fievel mentioned, dip your toes in, figure out the things you want to try, do them, but also learn from other people. Lots of communities are doing different things. Find somebody that's maybe similar to who you are or your needs, and learn from them. Communicate with the people across the country. Every community that we work with is different. They all have the same needs. They all have the same wants, but they all do how they satisfy those things differently. So you have to kind of create a system or a policy, call it what you will, that works for them. So that's the biggest thing is you've got to really know where it's coming from. And then from the technology standpoint is don't be afraid to try something. Nobody likes to fail, but with technology, there's always the opportunity for things aren't going to work exactly as you think they are. Kind of like Einstein, or the guys have said, they found 3,000 ways not to make a light bulb until they found the one way to work. Thankfully, we don't have to do that because other people are doing a lot of things. But technology is incredibly hard to keep up with. I've got a team of people that's all they do, and they can't keep up. So I can understand how a city could feel like they got behind.
Thank you.
Yeah.
Fievel, did you have something else you wanted to add to that?
Yeah, I would just like to make everybody aware that fortunately there is a coalition nationally, which John was very humble in his introduction. He didn't mention that he oversees that. So USDOT has sponsored a coalition called Cooperative Automated Transportation Coalition, and this is a collaboration of AASHTO, ITS America, and ITE. And within the framework of this coalition, there are several focus areas. There are several groups. Say, for example, there is a group that focuses on policies and regulations and legislative issues. There is a group that discusses strategic initiatives. There is a group that I have an opportunity to chair, is focused on technical resources. There is a partnership with the industry. So this information is available on National Operations Center of Excellence, and I would encourage the users to check this group out, and anybody can join any of these groups. Great learning experience, and there are a lot of resources. And we are looking for ideas from folks that are on the call because they come with some fresh ideas, and they all add value to the national development. Thank you.
Thank you, Fievel. Jamie, did you have something else you wanted to add?
No, not on that exactly. Fievel covered it very well.
Okay, sounds great. The next question is on cybersecurity. How should a municipality start to tackle the cybersecurity challenges, and what are the top issues? And we'll go to Jamie first on that one.
It's a great question, and I was just in Chicago last week, and I was a panelist with a cybersecurity specialist, and I learned more information just from him, considering what we do a lot of networking, so it's really interesting to hear. He said the top issue with cybersecurity is really two things. One, know what your network is touching. What are the connections? Who are you connected to? It sounds kind of crazy, but a lot of these networks do touch more than just traffic, so you need to know all those things. And two, at a very, very basic level, change all your passwords, change all your logins, have something that is not admin, traffic. I mean, literally, a lot of our traffic networks have very weak passwords. That's the stupidest thing to do, but it's a very basic level. Get that corrected first. And then the third thing he talked about was the firmwares. A lot of the things that are coming out on network switches and IP devices that you're deploying in the field, those firmware upgrades are security-based. That's why they're being put out there, is to make the security of all the devices stronger. So if you're well behind on your firmware updates or your software updates, have like your cell phone. You get the thing, you got to update your thing. A lot of those are about security. It's the same with all of your network devices. So those, at a very basic level, that's where you need to start.
Thank you, Jamie. The next question is for John. What is FHWA doing to understand and address the needs of transportation agencies and national roadway automation readiness?
Yeah, that's a great question, and I also appreciate Fievel both for his volunteer leadership to enable the continued and growing success of the Cooperative Automated Transportation, or CAT Coalition, and also to highlight it as a point of access for peer experience, but also to provide continued perspective and guidance to FHWA. In addition to continuing to support the CAT Coalition as a partnership through AASHTO and Institute of Transportation Engineers and ITS America. As I mentioned, we also do continue what is a foundation of the current US DOT automated vehicle policy statement, quote unquote 3.0, preparing the future for transportation, which is premised on continued and expanding stakeholder engagement. I mentioned the national dialogue on highway automation ended up engaging about 650 to 700 individuals, again, in pretty direct interactive eyeball contact in understanding the needs of transportation agencies and industries. And what we heard were through that dialogue, as well as through the request for information, request for comment, and ongoing conversation through initiatives like the CAT Coalition and others, is that there are challenges, there are opportunities, and there are needs. And as we move forward, we're kind of aware of all three of those facets of stakeholder perspective. A lot of the challenges relate to uncertainty, kind of non-linear predictability of the automation of the transportation system, and Robert provided some great practical insights into that in the context of automation of the trucking fleet at the national level. There are also significant challenges related to consistency and standardization and uniformity. And while a lot of this conversation has been about kind of the higher technology side of that cyber physical infrastructure, the roadway infrastructure system, quite frankly, a key element and a key challenge is the physical side, specifically traffic control devices, and the urgent need for more consistent compliance with the manual and uniform traffic control devices, and more reliable, not just installation, but maintenance, particularly of, yes, plain old pavement marking. And so a lot of the challenges that we've heard relate to maybe a return to the basics in just sound traffic engineering and responsible and accountable stewardship of traffic control devices, particularly the inventory and the asset management and maintenance of pavement marking systems. As far as opportunities, what we heard through that stakeholder engagement was there is an opportunity, if not an expectation, of the Federal Highway Administration to continue to serve a facilitative role, to remain open to insight, but also to allow transportation agency leaders to learn from one another. And as was just highlighted, as much can be learned from failure as can be learned from success. However, hopefully that failure does not have to be repeated in an identical mode from agency to agency. So, you know, if Fievel has an experience, or there's an experience in one of our three connected vehicle pilot deployments in Wyoming, New York, or Tampa, that highlights kind of an opportunity for a lesson learned, you know, learning from the experience, including the failure potentially of others, you know, is highly desirable. And so continuing that collaboration through the CAT Coalition, through involvement in webinars like this, is an important priority to the Federal Highway Administration. As far as needs, one of the two primary areas of need we heard from. One related to the need to not necessarily overemphasize, but to recognize the strategic significance nationally of automated freight operations at the national network scale. And so working with industry partners like Robert and others to understand the needs of truck automation, to facilitate the accelerated prototyping and demonstration of the viability of truck automation in corridors, and there's states that are leading that. Texas stands out as one in particular. So that was one of two kind of focused topical areas that we heard from the stakeholder engagement that is serving as a kind of point of focus, particularly at the national network level. A second relates to the need to engage the public safety and emergency response community, and certainly, and I highlighted in earlier comments, the significance of that when it comes to communication network development, communication network accommodation, interoperability, certainly a significant partner when it comes to considering cybersecurity and cyber resilience. And so kind of with an understanding of a need to recognize that the significance of automated freight operations and truck automation, as well as the need to more meaningfully engage as planning and deployment partners, the public safety and emergency response community, as I mentioned earlier in my introduction, we're initiating a project to develop a National Roadway Automation Readiness Framework and associated more technical concept of operations. And one of the likely directions for that initiative will be to, in a more consistent way, understand and perhaps categorize and define a prototypical set of automated driving system operational design domains. And operational design domains are what automated driving system developers use to specify and delimit the environment and the conditions and the roadway characteristics under which their system can safely operate. And one of the potential directions of this National Roadway Automation Readiness Framework and Concept of Operations may be to use a more standardized set of hypothetical, prototypical operational design domains as a basis for considering the readiness of specific types and specific classifications of roadway, recognizing that the most significant need and the most feasible layer of that network for more consistent accommodation automation may in fact be the highest level of the roadway network, which would be the interstate highways and the rest of the national highway network. So continuing to listen, continuing to support partnerships such as the CAT Coalition, continuing to participate in conversations such as this one, and then beginning to facilitate what will have to be a dynamic and incrementally evolved National Roadway Automation Readiness Framework and Concept of Operations are some of the things that FHWA is doing to continue to understand and address your needs as transportation agencies.
Thank you, John. That was very helpful information. Let's see, the next question is for Robert. What are the limitations, weather impacts to the technology that you're working on?
Great question. So we are here in sunny Arizona, and it's no coincidence that not just us, but our entire industry is focused on the I-10, which obviously covers the southeast and southwest of the United States. So at current levels, we can handle obviously great conditions. We can handle rain. We can handle dust storms and high winds. It did snow once this year in Tucson. It does this about every 7 years, but we can't do snow yet. It's not an insurmountable problem, but I always tell people, even at commercial deployment, this technology will be regional, it will be incremental, and it will be route specific. Luckily, I mean, we know where the freight corridors are, the Golden Triangle of Texas, certain parts of the country, obviously close to ports. So how the technology works is we map a route, and then the truck can run autonomously on that route. It's kind of like laying down the modern-day railroad. And so the kind of the sci-fi or media idea that we're going to snap our fingers and then robot trucks will be in all 50 states doing ice road trucking is really a misnomer. It will be I always tell people it'll be one tool in the toolbox of the big fleets, just like they offer intermodal and air freight and dedicated and LTL. They'll offer autonomous on certain lanes. And it's not that snow will be a forever problem, but it is an issue because we're an optics-based technology, and if we can't see, we can't drive. So right now we stick to rain, sun, rain, sun, and high winds. But luckily, there's plenty of freight to be moved in those regions as well.
Thank you, Robert. The next question is from David. As cities and public agencies start looking into preparing for automated vehicles in the coming years, what are the types of infrastructure investments and improvements that are anticipated to be needed from the public sector? I think, did you have your hand up there, Fievel? Did you want to answer that one?
Well, I think kind of related between the two questions. So I think one of the things that has come up in our discussions with auto manufacturers and the automated vehicle system operators like Robert is issues around the work zones. So what they say is one of the challenges is around the work zones, and that's something that is in our alley. And right now, the information that is available on the work zones is just a dot on the map. And that's one area that we in Maricopa County are focusing on. What we are trying to do is to convert our work zone data feeds in the step one into a national standard, which again, USDOT is kind of leading, and they have come up with a framework called WZDX. And we are one of the pilot agencies for that. And so we're working in the area of preparing our work zone data so that it is ready in future for connected and automated vehicles. So
Go ahead.
Yeah, I was just connecting between the two questions, but I think the second question is still open. So
Okay.
maybe, yeah.
Jamie, did you want to answer that one about from David?
The question about infrastructure investments and improvements?
Correct.
Honestly, I kind of agree with John. Where you start with the automated vehicles is at the really basic traffic engineering level. Have good paver markings, have good signing, have all of those different things that the automated vehicle is going to utilize to pick the lane and do what it needs to do. As you start looking at technology, the automated vehicles are a little different than connected vehicles. Connected vehicles need communication, vehicle to vehicle and vehicle to infrastructure, because they're, I wouldn't say dependent, but they utilize information from external sources. So the information, driver inputs, other vehicle actions are very important on the connected vehicle side. Automated vehicles are more, I just lost the word. They function autonomously. They really don't need a lot of external technology to do their job, but they need the physical infrastructure that we're supplying to them to be consistent so they are able to interpret what's in front of them correctly. Automated vehicles are not robots, they're not intelligent, super intelligent yet. You know, they learn by seeing the same thing 10,000 times. You throw them something they've never seen before, they can't interpret it. They can't intuitively make decisions. So to make automated vehicles work best, they need to see the same thing every time and to be able to interpret the same way. So it's a little bit different depending on which technology you're talking about, connected versus automated. Hope that helps.
Yeah, this is Fievel, and let me add a little bit. I think just on the continuation, I think Jamie makes a really good, I think good job in distinguishing between the two types of vehicles. So just adding to what Jamie said, so there are two ways to look from the infrastructure viewpoint. So one way to look at it is the impact of automated vehicle on our infrastructure. So for example, like John alluded to the striping issue. There could be like looking into the VMTs, how the VMTs would be impacted in the future. Now there are cooperative automated vehicles that you can platoon a bunch of trucks. Now, how would that impact our bridges? How would it impact our designs because of the loading changes because of that? So there are some like curbside issues, parking issues. So those are the things that the vehicles can impact our infrastructure. Now there's the other way of looking at it too. The other way to look at it is from a connectivity viewpoint, where we actually go and deploy the infrastructure on a digital infrastructure on our side. And that's where I think what we have come up with a process here, where we just take an application or an idea, and we run it through a pilot program. Then we do extensive testing, and then evaluate. And at that point, we evaluate the cost benefit and the investment levels needed for scaling it. And at that time, the decisions are made to go, no go, or in this technology we will mature, things like that. So that process of piloting, testing, evaluating has been very helpful for us, for our infrastructure, digital infrastructure investments.
Thank you, Fievel. And John, you wanted to add to that one as well?
Yeah, just kind of complementing what's been said, maybe amplifying a little bit. I mean, and I think Mandy made the point in the introductory comments that it's important to kind of start with understanding what you have and where you are. And so I think kind of resonating with, if you will, quote unquote, dumb old signing and marking, particularly the marking side. You know, if you're in a public agency and you don't have a robust inventory protocol and asset management capability for your pavement marking and your signing, it's going to be very difficult to be able to assess the quality of that traffic control system and its readiness to accommodate automated vehicles and to present kind of a consistent, predictable environment just from a pavement marking and static signing standpoint. So I think it begins kind of at the tactical level with traffic control device inventory and asset management discipline, including the extension of that, of course, to you know, what some would call the oldest ITS device, the traffic signal. And I mean, it's kind of humbling at the national level to be reminded of the variability of the quality of our traffic signal systems. There is a kind of an automated traffic signal performance management capability that's being advanced by FHWA as part of one of our Everyday Counts initiatives to make the performance assessment and performance management of existing medium to low tech signal systems more accessible. There was a TV news coverage about a year and a half ago of the signal system in Gary, Indiana. And at that time, Gary, Indiana had about a little over 90, just under 100 traffic signals, of which almost a quarter, I think it was about 23 of the signals, were not operating. And I don't mean not operating well, that they hadn't been retimed. I mean, they either were in irretrievable permanent flash or they were dark. And so, you know, I think while there are, you know, and again, thanks to leadership like Fievel, you know, there are certainly some model urban environments when it comes to traffic signal capabilities. There are some environments at the other end of the spectrum, and if automated vehicles are going to rely on city-to-city consistency, addressing kind of how that lower part of the population when it comes to traffic control system quality and reliability comes up is going to be as much a challenge as advancing the bar for the leading edge cities. So I think a lot of it comes back to basic inventory and asset management of traffic control devices and traffic control systems.
Thank you, John. Well, that is actually all the time we have for today. I want to thank Mandy and Jamie, Fievel, John, and Robert for sharing their great knowledge and experience with us. This is Rita Cassida, and it's been a pleasure moderating the program for you today. Please remember to register for the next program in the series titled Talking Top Tech, Augmented Reality Edition. It is scheduled on Thursday, December 5th at 10 a.m. Central. Please don't forget to fill out the evaluation form. The link to the survey will be emailed after the program today. Please note, due to the free form format of this program, it is not eligible for CEUs. A recording of today's program will be available in the APWA Members Library and on YouTube within a week. APWA members can log into the library to access past Click, Listen, Learns and Talking Top Techs and conference content free of charge. Not an APWA member? Take the Members Library for a test drive. Spend 2 weeks accessing all the materials in our Members Library for free. Look for the link to sign up in your email after the program. Thank you for your attendance and participation during the program, and have a great day.